Hey everybody, welcome back. This is session 3 of ASP.NET without Windows, and we're almost done. This is the home stretch. So if you remember in the last session, we wrapped up by scaffolding out our Math API, which is a very simple ASP.NET Core MVC application that was designed to take a verb, be it add, subtract, multiply, or divide, and also a couple numbers, and then perform whatever action we gave it. So if I say add and give two numbers, it adds the two numbers together. But towards the end of the demo, we learned we had a couple issues. If I was doing a divide with two uneven numbers, then I would get back a even number and not the proper floating point response that I was expecting. So this is a good opportunity for us to set up unit testing, which you may or may not be doing anyway. But I always like to show the practice because it's a good practice to get into. And with .NET Core, it's kind of built into the framework where I can scaffold out a unit testing library with the command line and then quickly start writing my unit tests. So I'm going to show you how to take our Math API and build a unit test framework with .NET New. Once we get unit testing up and running, we'll talk through a couple of deployment strategies. Specifically, I'll show you Azure App Services and Docker because those are kind of the most common. And then we'll wrap up with a couple of my final thoughts about ASP.NET Core in general and where it's going from here. Now let's get started. The last time I was with you all, we generated two different projects. Let's open up Visual Studio Code and take a look. The first project was our Math API.web project. And if you recall, this was a simple controller that had four different actions on it: add, subtract, multiply, and divide. And given a particular route, an action would execute. So add would add two numbers together, subtract would subtract two numbers, so on, so on. The actual logic for this addition, subtraction, multiplication, and division was inside of our Math API library, specifically our math service. And if you remember to the end of the last session, we learned we had a couple issues with division. Well, specifically, I'm expecting floating points and I'm not getting floating points. So I have a couple things that I need to go through and make changes to. But how do I ensure that I am getting the right results before we go out into production or even into development environments? Well, this is the perfect use case for unit testing. And I want to show you how we can do unit testing in a .NET Core environment pretty easily. And first thing I'll do is I'll close a couple windows. We'll scaffold this out. And we'll go back out to the terminal. And we'll clear our screen. For the previous two projects, I used Yeoman to generate out the scaffolds. And you could do that as well for unit testing. But for this particular case, I think it's worthwhile to go ahead and use the .NET New command. The first thing I like to do is create the directory for my tests. So we'll say Math API library.tests. The reason for this naming is that I'm testing specifically units inside of my Math API.library class. So I want to make sure my names are semantic. They should describe what I'm actually testing. If I cd into that test folder, there's nothing in here. So we should generate the proper .NET New template. Now recall back to the first session where we talked about what templates are available, what should you type. I want to use XUnit. Now I have a choice. I can use MS Test, which is good, and if you're comfortable already with MS Test, you can use those templates. Or you could use XUnit, which is also fully supported with .NET Core. If you use another unit testing framework out there, such as InUnit or so on, they most likely already have .NET Core support available. You just need to go look at those resources and look to see what you have to do. But I want to create a new XUnit project. So I'll say .NET New XUnit. And my new test project is generated. Over in Visual Studio Code, we'll see the new project. with my CS proj file generated for me, plus my unit test by default. We need to make sure we run .NET Restore to pull down the proper XUnit packages. That only takes a moment. And we also need to tell mathAPI-library.test about our mathAPI.library file. Again, this is using the .NET add reference command. And we'll link that to the CS proj file in math library. And back in our unit testing file, we'll change the name of our class to math service tests. And while we're at it, we'll go ahead and rename the file as well. And then we'll have to start creating some tests. With XUnit, it uses the idea of facts, that when I do something, a result should happen. So we'll say in this test, should add, we'll say should add two positive numbers. The first thing we'll do is we'll scaffold out our new math service. We have our expected response, which should be 5 plus 5. In these cases, you might just put out the raw number, so 10. And then our result is service.add 5 and 5. Now I need to make sure that I have the proper using statements. So we'll get math API library. If I add 5 and 5 together, I expect to get back 10. To tell the unit test what this expectation is, I have to do an assertion. I'm asserting that the expected value 10 is equal to the result that I get, which is service add 5 and 5. After a quick build, everything works. I'm going to come back out to the command line. We'll clear our page. And I execute my test by saying .NET test. .NET test will go through, run the appropriate unit tests. See, I had one test, and that test passed. Everything was great. If I had a failing test, so let's say, for example, I accidentally write a bad test where 5 plus 6 is expected to equal 10. Now, you and I both know that's not right. The service is going to have the correct response, but I want to show you what happens in case of a failure. So we'll clear our screen again. We'll run .NET test. And we'll see while running our test, we had an expected value of 10, but our actual result was 11. That means our test failed. And it's telling me that the failure was inside of should add two positive numbers. I should go back and fix that. And now I'm going to take a moment and go through and write a couple different sets of tests for my addition, my subtraction, my multiplication, and then finally my division. And we'll come back and we'll see if we can fix the obvious bugs in our application. All right, let's go ahead and stop here. I have very basic tests for all 4 of my methods: add, subtract, multiply, and divide. If I go back out to the command line and I run .NET test again, I should have 4 passing tests. And I do. Everything's great. Now let's go in and test a couple edge cases, specifically with divide. So I want to set up a fact, and I want to say should throw exception on divide by 0. Okay. I have my service set up, new math service. And this time, instead of setting up an exception and then a result and testing if those are equal, I need to gather the fact that a exception should be recorded. So I'm going to say var exception is equal to record exception, and we'll pass in a call into our service to divide. We'll say 25 by 0. And we know when this gets called, so 25 divided by 0, you can't divide anything by 0, and it should return a divide by 0 exception. I want to assert that this is of the type divide by 0 exception. And I'll test the exception. So if there's a case where divide by 0 is not the exception type, my test should fail. Well, let's go back out to the command line and give this a test. So we'll say .NET test. And everything passes successfully. I got exactly what I expected. Now I'm going to set up another test. And for this test, we'll say should return floating point result. Well, let's set up a floating point result. I'll give it a real easy one. If I divide 3 by 4, my result should be 0.75. If I run this test, I see I have an error that I expected a result of 0.75, but my actual was 0. So I need to go in and make some changes to my application. Now to make a change to all this, we want to go into our math service, and let's try something simple like divide a double and by another double. Going back out to the terminal, let's run our test again. And we get a failing test. So let's see, we're expecting a divide by 0 exception. So our test that originally was passing, the should throw exception on divide by 0, is not passing anymore. So that's interesting. What could the problem be? Well, this is a really interesting problem. When you divide 2 doubles together, or 2 floating points, the result is actually not a divide by 0 issue. This returns a value. The value in particular is infinity. But we're not really testing for that right now. We want to make sure that original test passed. So let's do a quick check. So if number 2 is equal to 0, let's throw a new divide by 0 exception. And we'll see if that all builds. All right, everything builds successfully. Let's try that test one more time, see if that fixes it. And it does. Okay, so now my original divide by zero exception passes like it should. And then the new test, which was to check that 3 divided by 4 was equal to 0.75. That test passes now as well. So this is really cool. I have a series of passing tests for different parts of my API. That means what happens if I go through and run the application. Let me start debugging, and let's launch a browser. All right, so the first ones are pretty obvious. Let's try add 5 and 5 again. That returns 10. What happens if I subtract 5 and 5? I get 0. What happens if I multiply? I get 25. Now for the fun one. Let's make a big number. 25 divided by 5. That returns 5. Let's do 3 divided by 4. Returns 0.75. Exactly what I'm expecting. So thanks to unit tests, I was able to figure all this out at test time instead of at runtime when my application is up and running. I hope this little primer was useful for you. I'm not going to go too in depth, especially because you have to get into one unit testing framework or another, and we don't have necessarily time for that. I really encourage you to pick up unit testing because unit testing is immensely useful across multiple parts of your application. And even though we're on .NET Core and we're running on Linux, we still have unit testing frameworks at our disposal, whether I want to use MS Test or if I want to use XUnit or InUnit or whatever else you might have out there. You should use something because it's much harder to debug when you don't have any sort of test framework set up. Since we've wrapped up unit testing, we know that our math API works to a certain degree. It's time to talk about deployment. How do we get this thing out into the wild? And specifically, I'm going to show you 2 different types of deployment options. First is to Windows Azure web apps, and also I'm going to show you Docker. Now, of course, these aren't the only ways to do deployments. You can run ASP.NET applications on your own web server, and I'm first going to show you how you would do something like that. The general idea is that you need to do a publish. Let's collect all the binaries necessary to run the math API, and let's package those into a folder, and then you can take that folder off to any server that you want to run it on. One thing to keep in mind is that when we do a publish on a Linux machine, like currently I'm on a Linux machine, I have to run those binaries on other Linux machines. They can't really go across into Windows or even on Mac without being recompiled. Another thing to keep in mind is when we do a publish here from the command line, this is only good if you have the .NET SDKs installed, and the .NET runtime. If you don't have the runtime installed, there's no way for you to run the executables that you have. Well, let's start from the command line. As we have already talked about, we have 3 projects: mathAPI.web, mathAPI.library, and then a set of tests for the library. In the first section, we talked about the .NET publish command. This command lets us build the current version of the application and spits out the output into a certain folder. So for .NET publish, I specifically want to run the release version of it. You don't want to push out your debug information. You want to make sure that all the compile time constants are turned on that are appropriate for release mode. So let's set it into release. Then additionally, I want to set the output directory to a folder called publish. Now the reason I'm using double dots here is when this publish happens, it's going to happen in the context of the mathAPI.web folder. So I want to make sure I go one directory up. And finally, I need to tell .NET publish which project I like to build, and that's my mathAPI.web csproj file. This command will run. It'll first build the mathAPI.library it will load and build math.api.web. When it's all done, the outputs of both these projects that are necessary will be pushed out into the publish folder. So if I cd into publish, here is a list of everything that is necessary to run our math.api.web project. One thing to keep in mind if we scroll up in this listing is that I only have DLLs for my web project and my API project. That's because ASP.NET Core applications are just libraries and they get run independently. We don't have a native app model built around these DLLs. So how do I run this application? Well, let's imagine you take publish and you go put it somewhere. You're going to run this behind something like Nginx, or you're going to run it behind HA proxy. And that's if you're running on Linux. If you're running on Windows, you'll probably run it behind IIS, most likely. But how do you run a DLL from the command line? Because that's kind of the first starting point. You can figure out the rest afterwards. Well, using the .NET command, if I say .NET and tell it run math.api web.dll. Now, notice I'm not using any other commands. There's no .NET run, there's no .NET build, there's no .NET anything. It's just .NET math.api.web.dll. When you call the .NET command like this, it will take the DLL and automatically start running it. No build process at all. That means I can take the local host and open it up. And let's say add 5,000 plus 5,000. And that returns 10,000. Exactly what I'm expecting to get. And all this is running locally. I'm going to leave it up as an exercise to you all to figure out how to properly set up this sort of environment if you need to run it like this. I don't have any use cases that have ever required me to run the DLL manually. It's always been through another mechanism. The next deployment model that I'd like to talk about is Windows Azure App Services, or Windows Azure Web Apps. And this is a common way for a lot of developers to push their applications out into the wild. Windows Azure is a great system. It's easy to deploy, and a lot of this just magically works. There's very little that you need to do on your end. So how do we take this current application and move it into Windows Azure App Services? Well, first, let me do a little bit of cleanup of my publish folder, and I'm going to show you my current Git directory. Now, I didn't show you any of this. It was stuff I did behind the scenes, but I created a Git repository for the entire application, and I committed to it step by step as we went through the project. All the source code is going to be available to you afterwards, so you can download it and take a look at what I've done, and hopefully try to get working on your own systems. But I have a current version of my application that's completely clean, it's committed and ready to go. And that's going to be important here in a moment. If I open the project up in Visual Studio Code, you'll notice I've added a new file in the meantime, and that's called .deployment. And this is useful when I push up into Windows Azure App Services, because it tells App Services which one of my projects is the one it should build and run. If I don't provide this, the subsystem Kudu, which does all the deployment, it'll try to figure it out, but with .NET Core applications, it'll normally fail and it'll give you this weird error that says it can't figure out which project to build. So we're just going to tell it which project is our entry point into the application. Obviously, before you can push to Windows Azure App Services, you need to go set up an app service. And I've already taken the liberty of doing that and creating one called ASP without Windows. If we go to it, it's not going to work. It'll give us the default landing page because there's no code running up in our app service. Let's go ahead and close that. And let's talk about different ways of getting our code up into app services. Primarily, you could use web deploy if you're running in Visual Studio proper. We don't have Visual Studio. We have Visual Studio Code, but that's not really the same thing. I could use Visual Studio Team Services. I could deploy via GitHub or Bitbucket. Heck, even Dropbox or OneDrive, which I don't really recommend except for demos. But for our uses, I'm just going to use a local Git repository because I'm already using Git, and it's one extra step at the command line to push all my code up into Azure via a Git repository. So I'll say local Git repository and OK. I've already set up a user account with a Git repository. So notice my Git clone URL is kevgriffin at my fully qualified URL for Git. If I go out to the command line, I can set up a new Git remote URL by saying git remote add. We'll call this Azure ASP without Windows, and I'll drop in the new URL. And with this new URL, I can do a push up into Azure, and specifically my master branch. And I'm going to do a -u because this is the first time I'm pushing. I'll have to get my password. And then we sit back and wait. And there's a couple different steps to this process the first time you deploy. So let's just sit back and watch. First is pushing up the repository, and then a subsystem called Kudu kicks in. And Kudu is what Windows Azure App Services uses for all its deployment needs. It's something we can customize quite a bit. And it's also the reason I had to create that .deployment folder. So the first thing that happened, it pulled down the Git repository that we had pushed up. It looked to see which project we told it needed to get deployed, and that was the mathAPI.web project. It's reading that file, and MS Build is now doing a .NET restore on first the mathAPI.library project, and then here in a couple of seconds, it'll do the same thing on the mathAPI.web project. It's important to keep in mind that this is running on a Windows subsystem. It's not happening on a Linux subsystem. But because of the power of ASP.NET Core, I can write my code once, and because of the .NET standard, it will work on whatever OS I'm deploying to. It's also worth noting during this process that there is a preview of Windows Azure App Services that runs Linux instead of Windows. We're not going to show it off because I don't want to show anything that's currently in preview, but the same idea theoretically will work on Linux-based app services in the future. Once the .NET Restore is done, then it's going to run MS Build. So build both projects and deploy them to the appropriate location. And then Kudu will kick off the new executable. And we're all done. If I switch back over to my Azure portal and I go back to the URL, it should come up with a blank page, because remember, this app didn't have any default view at all. But what happens if I go to /add 550? I get back the response I'm expecting, 550. And all my different commands should work. Let's try divide. Returns 10. So excellent. My API is now running up in the cloud, and if you had access to it, you could go run this API right now. The last type of deployment strategy that I want to talk about is Docker, and this isn't meant to be an in-depth education of what Docker is, why you should use it, and how it would fit into all your deployment strategies. So let's talk about how we can put mathAPI into a Docker container. Now, one thing I'm not going to show you is how to install Docker. I already have Docker installed. It's a couple commands to get it installed on Linux. Also, you can install it on Windows or on Mac, and it should all these commands should work exactly the same way. The reason we can use Docker, and Docker works well to begin with, is that Docker underneath the covers is all Linux. And because we are using ASP.NET Core on a Linux machine, we can take advantage of the fact that we have a Linux compatible version of our application and push that into Docker, which is all Linux. The first part of building out any Docker installation is to create what's called a Docker file. I'm going to open this up in Visual Studio Code. And a Docker file is essentially a recipe for how Docker should create an image of your application. And then we can take that image and we can push it anywhere we want to. It can run on DigitalOcean, it can run on Windows Azure, it can run on AWS. It doesn't really matter where it is. As long as where it's going is running Docker, we can push these images out and they'll run the same way no matter which environment they're in. Now, what do we do to start building out our Docker image? Well, the first part of a Docker file is the from line. And this tells Docker which base image we would like to base the rest of our application off of. And without going into too much detail, I'm just going to tell you we're going to base this off the Microsoft.NET image, specifically the latest version of it. What I can tell you is that when this image goes to load, it's going to check Docker Hub, which is a repository for public images, and it's going to get the latest version of the .NET image. And at the current moment, the latest version has the appropriate SDK and runtime that we need to run our application. The next thing we want to do is we want to copy our current working directory, which is mathapi.library, mathapi.web, and also the test, but we're not going to do anything special with those, into our brand new image called app, specifically into a folder called app. When we're inside that directory, we're going to set inside our image, we're going to set our working directory to that app folder. So imagine we're in the image. There's only files that we just copied in. We're going to CD into the app folder. I need to set an environment variable, ASP.NET Core URLs. And I'm going to set this to HTTP and tell it bind to any URL on port 5000. And without this line, my app may or may not work. So it's easier to put it in than to leave it out. The next step is, because I'm running inside an image, none of my dependencies have been installed yet, or I can't guarantee that my dependencies have been installed. So I need to run a command inside the image called dotnet restore. And specifically, I'm going to call dotnet restore on my math API .library. Oh, that means I need to update my working directory to make sure this is pointing at mathapi.web, because that's where we're going to do all of our work. I also need to remember to run .NET Restore inside the current directory, which is mathapi.web. So this ensures that both my library and my web project both have the dependencies that they need to run. Now this application is going to run on port 5000 by default. I've already set the binding above. That makes sure that the Linux subsystem binds to the appropriate IP addresses. But then I have to tell Docker to allow traffic on port 5000. If I forget this line, all the ports going into my Docker container while it's running, they're going to be blocked. I won't be able to send any traffic in or get any information out. So I need to make sure I open up that port. Then finally, I want to set the run command. And this command tells Docker to start a particular application inside of our container. And if that command ever dies for any reason, say we throw a hard exception or something bad happens and the application crashes, then our container is considered dead. It should shut down, which means from our end, we'll have to restart it or create a new instance of the container. Now I'm going to save this off and head over to the terminal. I'm going to run a command called docker build the current directory, and I'm going to name this file Azure ASP.NET without Windows, and we'll just call it 001. And there's various parts to this process. First, we have to go download the current image for .NET Core. Depending on your internet connection, this might take a moment. But the good news is once we do this once, we don't have to do it again unless the version changes. This gets cached away for future use. All right, the last couple steps ran pretty quickly, so let me scroll back up and we'll walk through it. Like I mentioned, step one was pulling the base image, which is .NET Core, and that comes down from a location called Docker Hub. And then we can tell each other step that runs. My files get copied into our image. I set the working directory inside of my image. I set the environment variables. I run .NET Restore, and this is inside of our Docker image. So notice here's the output of .NET Restore for the library project, and then again for our web project. Finally, I expose port 5000, and then I say the run command is .NET Run. Along the way, you'll see that we're setting up various breakpoints. These are hashes that describe the current state of the file system as our image builds out. What's nice about this is if I ever need to rebuild my project, if certain steps don't change the file system in any way, they don't have to rerun again. They just pull from a cache, and that means my builds go really fast. For example, if I run this build all over again, notice it's pulling everything from the cache because the file system inside the image hasn't changed. That saves you from having to go through this process over and over and over again if you make small changes that affect towards the end. Now, there are a lot of theories for how to properly optimize a Docker file. I'm not going to talk about any of that, but there's a lot of room for improvement in this Docker file. For now, I'm just trying to show you how everything kind of fits together. The next thing I want to do is run or create a new container based off this Docker image. All right, so I just ran the docker run command, and there's a couple different pieces of this. So first, docker run will create a new running instance of any Docker image. The -d runs it in daemon mode, so if I forget to run that, it will pipe all the output from our running Docker image or Docker container out to the console, which I really don't want. I want it to run all in the background. So I use -d. -p sets up port binding. Now remember, if I expose port 5000, I now need to map my local ports to port 5000. So because this is port 5000 inside of Docker, I want to say that if I use local port 5000, it should map automatically into port 5000 in my Docker container. Now I'll show you what I mean here in a moment. This is really useful when we go into production. So if I'm running on port 80 up in production, my web app itself still runs on port 5000, but I can map port 80 into port 5000. And I'll show you a more practical example of that here in a second. I need to name my container, or if I don't, it's going to get a random name, which is fine, but it's easier for me to keep track of if I name it myself. And then finally, I have to tell it which image I want to use. Specifically, I want to use my AWW 001 image that I just created. If this all works correctly, Docker will spit out a hash, E64 and change. This is the ID for the current running container. I can check to see if everything's working correctly by saying docker ps. This will tell me what containers are running and what commands are being run inside of them. So I have my AWW 001 container running. The command was .NET run, and it's on localhost port 5000, and it's binding to port 5000 inside the container. So now if I open up a browser and go to localhost port 5000, it loads and doesn't do anything. So let's try to do an add. Let's say 500, 500. That returns 1000. Now remember, I'm not actually running .NET Run anywhere on my local machine. All this magic is happening inside of Docker right now. If I ask Docker to give me the logs for AWW, it will tell me here's what's happening inside of that particular container. I can kill or remove the container by saying docker kill AWW. And now if I go back into my browser and try to refresh, it's not going to work because I've just killed that container and the web app that's running inside of it. Since we've proven our Docker image works, we now need to do something with it. So how about we push it up to a live server running on the internet? And for this case, I've already set one up running on top of DigitalOcean, AWW Docker, and its current IP address. If I try to go to that IP address, you're going to see that it doesn't really do anything. The server's up and running, but there's nothing listening on port 80. So let's go through a couple of the motions of setting this image up to run on top of our machine. Well, back at the command line, I need to take the image on this current machine and push it up to a central repository where I can run it. And that repository we're going to use is called Docker Hub. And I'm already signed in. I don't have anything uploaded right now. You'll see my view is kind of empty. And I want to take my AWW image and I want to push it up to Docker Hub. And that's done with the command docker push and then the name of the repository. So you remember earlier why I named it a certain way. That's so I can push it up and it goes to where I expect it to go. And when it's called push, it's going to take the different layers or the different snapshots of this application or of this Docker file, and it's going to push those up to Docker Hub. And that can take a moment. And when it's all done, I can come back over to Docker Hub, give my page a refresh, and I'll see I have a new repository sitting here waiting for me. I can dive into the details, and it shows me all the information I need to pull this down onto another machine and to use it. So let's do that. I'm going to go remote into this remote machine that I've already set up. And the command to pull down that image was docker pull 1kevgriff AWW001. And again, this takes a moment because I'm pulling down this Docker image to a completely different machine. And we're all set. My image is downloaded, so I don't have to go download it later. And I'm going to clear the screen again. And let's go run it. And here's the command that's going to run Docker on our remote machine. Let's walk through this step by step. It should be a little bit of a recap of what we did earlier. By saying Docker run, I'm telling Docker to take a image and create a brand new container and run that image inside of the container. Let's run it in daemon mode so I don't have to worry about it. I'm doing the port binding to localhost, this time using the all zeros. And I want to bind the external port 80, this is the internet facing port, to port 5000, which is my internal facing port. So any request coming in on port 80 should magically go to port 5000, and it works no matter what. I like to name the container AWW internally, so if I need to stop it for any reason, I can call it by name. And then I want to use the image 1kevgriff AWW001. When I call this up, the image starts up in a new container, and this is a hash that represents it. I can also call it by name. And if we give it a moment, I can come back over to Firefox, and I'll add the IP address and say add 5000 and 5000 and hit enter, and it returns 10,000. So my Docker image that I created locally, I tested it locally, I pushed it up to Docker Hub, I pulled it from Docker Hub on an external server and ran it, and it all runs exactly the way I expected it to. That is a end-to-end deployment. Now, obviously, this isn't the easiest way to deploy Docker in production, but that is its own 20-hour course all by itself. And I really encourage you to go look this sort of stuff up. Learn Docker, because it's going to become very important in your DevOps cycle over the next coming years. And now, time for some final thoughts. I'd really like to take a moment and say thank you for taking this journey with me through ASP.NET without Windows. I know it can be a little intimidating, especially since the past 15 years of our .NET careers have been focused primarily on Windows and Visual Studio and working in that ecosystem. It's a new path entirely. We can take a lot of the concepts we already understand, like C#, ASP.NET, MVC, and now we can adapt that to a brand new environment. So I hope that we covered the main goals of this series. The first one was to provide you an introduction to the new concepts of .NET Core. We showed you command line stuff. How do you scaffold out an application? How do you put all the pieces together? What's the big difference between an ASP.NET Core application and, say, an application built on ASP.NET 4.5? We talked about development environments using Visual Studio Code as a text editor instead of something like Visual Studio. How do I do my build and my NuGet package management all from the command line? And then we showed you how to actually build out a simple application in .NET Core. This included simple things like unit testing and also a couple deployment strategies. And as our time together wraps up, what should you do next? Well, I want to encourage you to go download .NET Core if you haven't already. And try this on your Windows machine, try it on your Mac or your Linux boxes, and start building some simple applications. Try them in a couple different configurations to see what works, see what doesn't work. Ask questions. Because as this ecosystem changes, we need people to ask questions. Even if you think it's a silly question, ask it anyway. Because normally your silly question is just the lack of documentation. And we need to fix that as a community. Also, pay close attention to ecosystems like Node.js. If you've never worked with Node.js before, they're worth looking at because a lot of the ideas we see in ASP.NET Core are being copied almost directly from Node.js, just in terms of workflow and code management. It's still C#, but the ideas are the same. And then finally, it's still C#, it's still ASP.NET. If you've done any ASP.NET development over the past 10 years, you probably already know what's going on. You just have to learn the subtle differences. And remember, this is all for the better. Our applications are getting faster, they're getting more robust, they're getting more secure. So if you're being reluctant to go down the road of ASP.NET Core, I'd like to urge you to just give it a chance, because this is all for the better, and our applications are going to be better because of it. Again, thank you so much for hanging out with me. If you'd ever like to contact me in the future, please feel free to email me or send me a message on Twitter. And also my various websites are listed here on the screen. Thank you all so much, and take care.